In this unit, I'm going to define formally what we mean by a complex number. To do that, let's revisit the solution of a quadratic equation. And this time, we'll look at this quadratic equation here. X squared minus 10x plus 29 is 0. And we solve it using the formula for solving a quadratic equation. Off we go. X equals minus b, which is minus 10, which is plus 10, plus or minus the square root of b squared. B squared is minus 10 squared, which is 100, minus 4 times a, which is 1, times c, which is 29, all divided by 2a. 2 ones are 2. Let's tidy up what we've got. We've got 10 plus or minus the square root, and under the square root sign we've got 100, subtract 4 times 1 times 29, which is 116, all divided by 2, which is 10 plus or minus the square root, and 100 minus 116 is minus 16, and you'll see we've got now the square root of a negative number appearing in here, all divided by 2. Now the square root of minus 16 we can write as 4i, and all that's divided by 2. And if we cancel the factor of 2 in the numerator and denominator, all this will simplify down to 5 plus or minus 2i. And we've got two numbers here really. We've got one which is 5 plus 2i and one which is 5 minus 2i. And these are the two solutions of this quadratic equation. Now a number like this one, which has got a real part, which in this case is 5, and an imaginary part, which is the bit that's multiplying the I, which in this case is either 2 or minus 2, a number like this is called a complex number. We say that 5 is the real part, and either 2 or minus 2 is the imaginary part of the complex number. We have a formal way of writing this down. In general, a complex number is going to look like this. It's going to take the form z equals a plus bi, where a and b are both real numbers, and I is the square root of minus 1. And this is the general form of a complex number. We refer to A as being the real part and to B as being the imaginary part of the complex number. Let's have a look at some more examples. Okay. First example, suppose we write down z equals 3 plus 4i. This is a complex number where the real part is 3 and the imaginary part, which is the number multiplying I, is 4. So the real part's 3 and the imaginary part is 4. Suppose z was minus 2 plus 5i. Here, the real part is minus 2, and the imaginary part is 5. Both the real and imaginary parts might be negative. So in this example, the real part is minus 3, and the imaginary part is minus 9. What about a number like this one? There isn't a real part to this complex number. There's purely an imaginary part, and the imaginary part is 5. This is a purely imaginary complex number. And finally, if we look at, say, z is 17, this is a purely real complex number. If we wanted to do, we could write on an imaginary part, but it will be 0i. So in fact, all real numbers are complex numbers with 0 imaginary part. In the following unit, we're going to look at how we can start to add, subtract, multiply and divide complex numbers.